Hi everybody. Today we're going to be looking at quadratic graphs, and we'll be looking at specifically the axis of symmetry, and we're looking at some problem solving with quadratic graphs. So sit in tight, and hopefully this little tutorial is going to help you to understand more about quadratic graphs. Now, so we're going to start off with axis of symmetry. So just drawing a quadratic graph. Let's say we have something like this, which obviously is a parabola. I'm going to call this fx, and I'm going to call this x. Now I'm going to call this function maybe just x squared. Just going to give a random function to this, x squared minus 5x plus 6. Okay, so we got a quadratic function here, and we're going to be looking at something what we call the axis of symmetry. And we do know that the axis of symmetry is defined as the line that literally cuts the parabola into half, which is basically a mirror, creating a little mirror between one side of the parabola being reflected onto the other side. So we have this, what we call an axis of symmetry, and I just want to spend a little time to talk about how we could find the axis of symmetry given two scenarios. Now, scenario 1. Now, if we have the function, okay, there are obviously two ways. Usually for the AA students, in the IB AA students, specifically, you should be able to find the axis of symmetry with both the GDC and without the GDC as well. So it is important for you to know how to find the axis of symmetry by using more of an algebraic approach. Now, so scenario 1, so if you're given the function, we could use the formula for the axis of symmetry, which is basically x equal to negative b over 2a. In this case, I shall not go too deep into how the formula came about. It's not absolutely required in the IB level, but I will be happy to show you the proof if you're interested in it. Now, so we have x equal to minus b over 2a. Now, so a basically would be the coefficient of x squared, while b is going to be the coefficient of x. So in this case, if we put in the respective numbers into the formula, a in this case would be 1, because the number that's multiplied to x squared, that's 1. So that's the coefficient of x squared. And b would be negative 5, which is the coefficient of x. So if we put in the formula, you're going to get negative 5 divided by 2 times 1. So you're going to get 5 divided by 2, which is 2.5. So we know that at this point, this is going to be 2.5. So the equation of the axis of symmetry would just simply be x equal to 2.5. Okay, now, so that's the first scenario. Now, if we were to use the GDC, the calculator, we can actually work the same way on how to find the axis of symmetry. Now, so I'll just show you very quickly how we could do this with the calculator. So with the calculator, if I were to put this in, let's just clear this first. So this would be x squared minus 5x plus 6. I'll graph it. Okay, and if you want to find the axis of symmetry, now there is no specific feature that finds the equation of the axis of symmetry, but we do know that the axis of symmetry corresponds to the minimum point of this graph. So what we could do is that if we do second trace and we find the minimum point, you press enter and we move the left bound just somewhere to the left of the minimum point, the right bound to the right of the minimum point. So you're going to get something like this. Okay, you're going to get, well, I'll do this again. So the minimum point you could see is x equal to 2.5, while the y coordinate is negative 0.25. So it is the same values that we have. we have here, okay, which is x equal to 2.5. So again, with using the GDC, you should be able to find, so GDC in this case will find the minimum point, which should give you the same axis of symmetry, which is x equal to 2.5. Okay, so that's scenario 1. Now scenario 2, now this would be the ideal scenario. Now if I'm going to give you an equation that looks something like this, and let's say this number is 1 and this number is 3, and if we want to find the axis of symmetry in this scenario, when you're given the x-intercepts, all the zeros, then it is very obvious that this is the midpoint between 1 and 3. So what I could do, I could say that x is equal to 1 plus 3 divided by 2, which gives me 2. So in other words, if you are given the x-intercept, right, if this is given to you, you could find by taking the midpoint of the x-intercepts, and that would give you the axis of symmetry as well. Okay, so you got to judge based on the scenario given on how you could find the axis of symmetry, because these scenarios could happen in any question. Okay, so hopefully this gives you a rough idea how you could find the axis of symmetry. Okay, so we're going to move on to a question which I took from the Oxford textbook, just to give you a rough sense of how we could do that. Now, so it says, consider the graph given by the equation 0.4x squared minus 2x minus 8. Find the coordinates where the graph crosses the x-axis. Now, what I'm going to do is, if this was done with the AI course, then we could literally do everything with the calculator. But of course, in the AA course, if you were to have an equation that's given to you like this, and you want to find when the graph crosses the x-axis, that simply means that y is equal to 0, because at any point where the graph crosses the x-axis, all right, we know that the y coordinate is always going to be 0. Then all we need to do is we need to solve this equation that gives me equal to 0. Okay, but it's a bit too much work, at least for now, for the AA. Also, and this video is primarily more for the AI students, and I would like to show you how you could do this with the TI-84. Okay, so let's just put this onto the calculator, this function, and we will try to find the zeros from the calculator. Okay, so 0.4x squared, so I'll just change the equation. 0.4x squared minus 2x minus 8. Okay, I just need to check if I get the equation correct. Yeah, it is correct. So, and I'm gonna graph it. And there we go. We have two x-intercepts here. Okay, so what I'll do is I'll go to second trace and I'll choose 0. Okay, and I'll press enter. Now they're going to ask for the left bound. I'm going to find the one on the positive side first. Then I'll move this towards the right. Press enter. So you're going to get one of the zeros to be 7.62. Okay, so I'm going to write the answer first here. So in this case, for this question, the coordinates will be 7.62 and 0, and let's go find the other 0 as well. So I'll do another second trace. I'll go to option 2, then I'll move. Right, I got to move to the other side. So somewhere about here will be good. Right bound will be somewhere about here, and we got negative 2.62. Okay, so there we go. So this will be negative 2.62 and 0. Okay, so the next question, so we got this one. Find the coordinates of the intercept with the y-axis. This one I'm just not going to do it without the calculator. All right, because we know that with the y-axis means simply that x has to be 0, And when this is substituted into the equation, you're going to get something like this. So that should give me -8. So the coordinate should be 0 and -8. And you could find this easily from the calculator as well on where the y-intercept is. Now, in part C, it says find the equation of the symmetry of the curve. Again, you could use the calculator or you could use the formula. In this case, I'm just going to show it with the formula, which is x equal to -b/2a. In this case, a would be 0.4, while b would be -2. So again, if I were to substitute all these values in, I should get something like this. 2 divided by 0.8, so that would give me 20 divided by 8, that should give me 2.5. Okay, so that would be the axis of the equation of the symmetry. And of course, you could double check that with the calculator as well. Okay, and finally, it says find the point of intersection of this curve with the curve given by y equal to -5x cubed. Again, we're going to use the calculator to get this done. So I'm going to put in another equation, -5x cubed. I'll graph it. Alright, there seems to be one intersection over there, so I'll go to second trace. I'll choose option 5. I'll just get really close to this, and I'll move right. Press enter. So the intersection is x equal to 1.25 and the y is -9.88. Okay, 1.25 and -9.88. Okay, so that's how you could use the GDC to help you to find the point of intersection. But for the AA students, if you were to find the intersection, then you have to do the simultaneous equation between this equation and this equation. So it can be quite rough if you were to do that. But at least, like I said, this video is meant to be for the AI students primarily. So again, we're going to be using the GDC to get this done. Okay. So the next part of the video, I just want to talk about finding the equation of the quadratic curve by looking at the regression feature on the GDC. And of course, we could also use the simultaneous equation solver on the GDC. So I just want to show you both ways, and you could figure out which is perhaps the one that resonates with you the best. Okay, so I'm going to give you an example here. Now, so what I did is I'm just going to give you an equation, a graph that looks like that, and that's really it. And all I want you to find me is the equation of this curve. Now, the first way, if we're going to use the regression way, is we first have to identify a few points on the graph. Now, if I have a point here that I could identify the coordinates, this is -4, 0. Another good point to identify probably would be this, because that's where I could identify the coordinates as well. So it's -2 and -12. I could use this point if I want to. That's 0, -12. Of course, you could use maybe this point is perhaps not great. This point is probably good as well, which is 2, 0. Now, what we could do is when you want to use the regression, all you need is just 3 points. Okay, if you want to use 4 points, that's fine, but technically all you really need is just 3 points. Okay, so what I want to do is I'm going to put all these coordinates onto my calculator. So I'm going to do this. What I'm going to do is let me just quit this first. Now, what I want you to do is to go to stat, go to edit. What we're going to do is we're going to put in those numbers that we have here. So we have like 0, and we have I'll put in all the x coordinates first. So it's 0, -4, -2, and 0. Okay, I'll just pick the first 3, -4, -2, and 0, and L2. Okay, I'm going to put in the y coordinates for this. So the y coordinates will be 0, -12, and -12. Okay, so let's put this 0, -12, -12. Okay, so what I did was I chose the first 3 points. If you want to put more than 3 points, that is absolutely fine. Now, then what I want you to do is you go down to stat. I want you to go to calc. Now we're going to choose the option that says quadratic regression. Now what quadratic regression does is the calculator is going to find you the equation of the curve that fits those points that we just plotted on the graph. Okay, so regression is all about fitting points onto the graph. Okay, so if we graph it, let's see how it looks like. But that's not what we really want. We really want to simply find out what is the equation of the curve. So x list, we're going to call it L1, or the y list, which is the y coordinates, we're going to call this L2. And you're going to press enter, and you realize that you're going to get a to be 0, b equal to -6, and c to be -24. Now this becomes a bit of a problem, because if a is 0, then it means that we have a little problem, because this is going to create a straight line. So a has to give you a number but not 0. So in other words, there must be a bit of a problem with the coordinates, because look at L2. I forgot the last number is -12. Press enter. So I'm going to go back and do the same thing again. Stat calc option 4. Okay, oh, I think I chose the wrong option. It should be calc. I'll choose option 5. Okay, then press enter. This is what I get. I get a to be 1.5, b to be 3, and c to be -12. Okay, so I'm going to write this down first. So a is 1.5, b is 3, and c is -12. Now we do know that a quadratic function or an equation will always look something like this, which is ax squared plus bx plus c. So in other words, if I were to substitute in all these numbers in, I'm going to get my equation of this graph. Okay, which is 1.5x squared plus 3x minus 12. Now technically this is the easiest way, is by using the quadratic regression. Okay, now this works very well for the AI classes. Now for the AA classes, if this was a non-calculator paper, then we have to do it in a different way. And I could show it to you how this works. Oops, let me just try to clear this up first. Okay. Now, if this was done without the GDC, okay, this is how we're going to do it. Now, we do know that a quadratic function could look like something like this. We know that this is the most standard form of a quadratic function, but another possible quadratic function could look something like this. Okay, now why this can be written in this way is because we have the x-intercepts that is given to you. Okay, now we do know that in order for this to be -4, we could say that x plus 4 is equal to 0. Why is it equal to 0? Is because we know that on the x-axis, the y coordinate is always going to be 0. And when I solve this equation, it's going to give me -4, which is basically the same value right here. Now in this case, because this is +2, then I could say that x minus 2 is equal to 0. Okay, again, because the y coordinate is 0. And if I solve this equation, x would be 2. So in other words, if I were to write the equation, I could write something like this, which is x plus 4 and x minus 2. But the only downside is I do not have the value of a. And this is where I could do it if I were to pick another point on the graph. So if I were to pick another point on the graph, I could have picked this point, okay, which is 0 and -12. Then I will substitute this number into this equation. So it will look something like this, which is -12 equal to a, 0 plus 4, 0 minus 2. Okay, and if you solve this equation, you're going to get -12 equal to -8a, which means that a is negative 12 divided by negative 8, which again gives me 1.5, which was the same value that we have found earlier. Okay, but this is only primarily for the AA students. The AI students, you don't need to worry about this because you could use the GDC at any point of time. Okay, all right. So let me just clear off the pen markings again. And finally, another way where you could use the GDC to find the equation of this, there is another way to do it. Again, for the AI students, is that again, if you were to pick any of the 3 points here, if I pick this, and this point, what you could do is you could substitute all these 3 points into this equation. So it's going to look something like this. If I were to substitute this point into this equation, you're going to get 0 equal to a negative 4 squared plus b negative 4 plus c. Again, if you were to simplify this, you're going to get 16a minus 4b plus c. Now this is your first equation. Now you will do the same thing again for this point, which is negative 12 equal to a negative 2 squared plus b negative 2 plus c. All right, it's a lot of work. To be honest, I don't really encourage this way, but I just want to show you that this way actually works as well. So this is your second equation, because this could potentially lead to some problems as well. And of course, if we have this number here, you're going to get negative 12 equal to a 0 squared plus b 0 plus c. So you're going to end up to get something like this, which is c to be negative 12. Okay, and you got 3 equations here. And in fact, just by doing this, we have already found out what c is. Okay, but I just want to show you that if you want to save the trouble and you want to put all these 3 equations onto the calculator, you can actually do that. So let me just show you how you could solve 3 equations with 3 unknowns on your calculator. Okay, and you have watched my video on the TI-84. You would have found out how to use the TI-84 to solve equations with 3 unknowns. Okay, so I just want to show you very quickly how we could do that. Now, on your calculator, if you go onto apps, if you go onto apps, you should be in your calculator. You should be able to see this Polysmith feature on your calculator, and that should help you to be able to find. I don't really have that feature on this calculator, but again, if you would like to know how to do solving equations with 3 unknowns, please watch my video. I'll put that link to the video under the description of this video, and you could watch that, and it will show you how you could use Polysmith on the TI-84 for that. Okay, so but that's really something I just don't want to spend time on in today's video. But this is a very long way, so I would definitely encourage the first way if you would prefer to solve this, to find the equation of the curve. Okay, now I'm just going to show you an example here on how we can actually do finding the equation of the graph with another scenario here. So let's just quickly run through this question. So it says that the graph passes through the points 0, negative 9 and negative 1, 9, given that the equation of the symmetry is x equal to 4. So I think the best way to do this is graph it. Okay, so I have a graph. Now I'm not sure what a is, but I'm just going to see how this looks like. So this is y, this is x. Now it passes the points 0 and negative 9. So 0 and negative 9, so here will be 0 and negative 9, and it also passes through negative 1 and negative 9, so probably somewhere about here as well. Let's say if this is negative 1, right? And we know that the axis of symmetry is x equal to 4, so it's somewhere about here. Okay, so this is 4, so this will be x equal to 4 here. Okay, so the thing is, I have 2 points. I have the axis of symmetry, which obviously cuts the curve right through the middle, but again, you could obviously do a sketch of the graph for this, but in this case, if we're going to find the value of a, b, and c, what we could do is we could try to put in these numbers into the equation first. Okay, again, if we can do this with the calculator, then I think it's going to be quite obvious how to do this. So let's put this on the calculator. Since we only have 2 points, then I'm going to put that 2 points onto the calculator first, because we know that this is going to lead to a quadratic function anyway, isn't it? So if we do that, we can just instantly put this onto the calculator and just do the regression as well. Oops. Alright, that's the price to pay. Alright, well, that's where you don't get the real addition of it. You gotta have little ads that comes into it. Okay, let's wait for this ad to pass. So let's put this one. Little calculator. Now for the Star Wars. Perfect. Love it. Alright, let's just wait for this ad to pass.
Download Monopoly Go and play the new Star Wars event
this
today.
looks fun. Okay, there we go. There we go. This is not a paid edition of the calculator, so I will have ads on this. Okay, so we're gonna put this on the calculator. So I'm gonna do -1, then press enter. That will go 0. I'll delete this. Oops, sorry. This is 0. Oh my god. So -1. Let's delete this. This is 0. Then this will be 9, and this will be 9 as well. Okay, so I got 2 points, and I want to go to stat, go to calc, choose option 5, then I'll press enter. Now you realize something, you're going to get A to be 0, B to be 0, and C to be 9. This becomes a big problem because number one, we don't have 3 points. So again, this is a great illustration on why you absolutely need 3 points, because if you only put 2 points, technically it's only a straight line. So it doesn't really tell us how this can create a parabola. So remember, you always need 3 points. So we need to go back to the question again, okay? And we need to try to identify what could be another way for us to find the value of A, B, and C. Okay, but I think we have enough information to first find out what C is. Okay, now I think this would be a great way to start putting numbers into the formula, because again, we don't have 3 points here. So but we do know that when x, oops, okay guys, I'm gonna finish up this question in my next video, because I think my Apple Pencil has run out of battery. Unfortunately, it is what it is. So bear with me, I'm gonna make this in the next video, so just brace yourself for the next video that will be coming up very soon, okay, while I get my pencil charged. And so I'll see you guys very soon, and hopefully if you still like this video, please make sure you subscribe to my channel as always and like my video. Alright, the part 2 will be coming very soon. Alright, I'll see you guys very soon.